Hello, my name is Ian Rollo, and I'd like to thank Dr. King for the invitation to contribute this talk on modern hydration strategies and the impact of technology. The aim will be to provide an introduction to hydration and share with you some of our experiences in developing technology to inform hydration strategies. First, let us recap on why hydration is of interest. Water is the largest component of the human body. In fact, water accounts for approximately 60% of body mass in the average athlete, but this will vary depending on body size and body composition. Water plays an important role in numerous physiological processes. It functions as a solvent, providing a means of transportation of materials throughout the body. Is important for the delivery of nutrients, the transport of oxygen to the brain and exercising muscles, as well as the excretion and removal of waste products. Water balance is also important in blood volume and blood pressure regulation. And finally, and of most relevance today, water plays an important role in body temperature regulation. This is my statement, which I modified from a great quote from Cirio Farrell, who's a sword fighter in the book series Games of Thrones. All athletes are made of water. Do you know this? If you exercise them, the water leaks out. And we know the physiological consequence of exercise is the generation of heat. The main mechanism to dissipate that heat is through sweating. And let's be absolutely clear, we want our athletes to sweat. If the athlete is not sweating, the likelihood is they are not working very hard. The human body is designed to sweat. In fact, the largest of our organs, the skin, as I like to say, is perfectly perforated with millions and millions of sweat glands. So what is sweat? Well, primarily sweat is 99% water, but will also contain varying concentrations of different electrolytes. The main electrolyte found in sweat is sodium, together with its associated anion, chloride, which is why if you've ever been exercising and take a lick of your own sweat, it will taste salty. The losses of electrolytes will be determined by their concentration in the sweat, partnered with the rate of sweating, which can be influenced by genetics, but also by the training status of the individual, the intensity of the exercise, the humidity of the environment, the environmental temperatures, as well as the equipment which the athlete is wearing. And it's the evaporation of sweat from the skin's surface, which is the primary mechanism by which heat is lost from the body during exercise. And this prevents rapid rises in the body's core temperature. Sweat rates will range between 1 to 2 litres per hour. And understanding these fluid losses and replacing these fluids is important for maintaining the body's hydration status. Now, the process of sweating causes a deficit in body water. Despite having access to cool, palatable fluid, athletes still dehydrate during training and matches, leading to a phenomenon more commonly known as voluntary dehydration. The higher the sweat rates, the greater the risk of experiencing varying degrees of hypohydration, which can be classified as mild, which is the equivalent of losing 2% of pre-exercise body mass losses, moderate, 5% of body mass losses, and severe, 10% or more losses in pre-exercise body mass. Now, it's highly likely that individual athletes will be more or less sensitive to different levels of hypohydration. Nevertheless, the available literature suggests that hypohydration equivalent to 2% of body mass losses during exercise are associated with impaired thermoregulation, a decrease in cognitive performance, impaired skill execution, reduced aerobic performance, and finally, and importantly, an increase in the perception of effort, all of which it is reasonable to suggest are important variables to consider for both training and competition. So what should we do about this? Well, this slide shows the sweat rate and sweat sodium data from over 1,300 athletes tested by the Gatorade Sports Science Institute over several years. This is a very comprehensive group of athletes with varying ages, body masses, who have exercised in a variety of environmental conditions. As you can see by the graph on the left-hand side, there is a range in the sweating rates and also a range in the sodium lost in sweat. So quite simply, this slide demonstrates that athletes sweat differently from one another. Even athletes within the same sport, when competing in the same training sessions, in the same environmental conditions, will sweat differently from each other. And if you're interested to read more, we have just had a published paper that reports the fluid balance of professional soccer players, professional football players, in response to training in different exercise intensities and in different environmental conditions. Now, in healthy individuals, the human body is remarkably capable of regulating total body water. The sensation of physiological thirst is stimulated by either a decrease in the amount of water in the blood, also called hypovolemia, or by increased plasma osmolality, which is an increase in the concentration of dissolved particles such as sodium or glucose, for example, in the blood. Both of these changes occur with hypohydration as a consequence of sweating. The perception of thirst can also be increased or decreased by signals arising from the mouth, the throat, and the stomach. However, other factors unrelated to thirst and hydration status can also affect how much fluid an athlete consumes. These include simply how much an athlete likes a beverage, the availability, as well as social and cultural factors. A key point to consider here is that athletes will already be hypohydrated when physiological thirst mechanisms are stimulated. So considering hydration strategies, we can put these into two main categories. The first is drink to thirst, also known as ad libitum, and in principle states that our sensation of thirst is more than adequate to dictate fluid intake during exercise. The second is planned drinking, which can be defined as drinking a predetermined amount of fluid. And this volume of fluid is determined by the knowledge of individual sweat rates. It's important to note here that both these guidelines state that players should avoid hypohydration greater than 2 to 3% of their pre-exercise body mass. And both absolutely recommend that athletes should not accumulate body mass during exercise through fluid intake. Both state they support performance. And as such, I've prepared this slide as an attempt to provide a guide as to which plan to follow, because of course it depends. As the duration of exercise exceeds 90 minutes, there is more of a need for a planned drinking versus ad libitum drinking. In addition, as we move from cool to hot environments, again, planned drinking is advised. But this is also dependent on the intensity. High intensity, prolonged exercise in the cool may also require planned drinking. And this is also linked to the risk of fatigue. Low risk of fatigue, ad libitum drinking is fine. But with a high risk, hydration strategies begin to be combined with fueling strategies so that then an individualized plan is recommended. Finally, for those individuals playing sport for enjoyment and participation, then drinking to thirst is more than acceptable. However, in my experiences, we shift from participation to a performance-orientated outcome, then a planned drinking regime is recommended. Now, this slide is a schematic of how to measure sweat rates and sweat sodium concentrations in the field. Often, a urine sample is collected prior to the test as an indicator of the athlete's pre-exercise hydration status. Then, to measure sweat rate, body weight must be taken before and after the exercise session, with the athlete in minimal clothing. The athlete's drinks bottle also needs to be weighed before and after to correct for any fluid consumed. To measure sweat sodium concentration, absorbent patches are placed on the athlete's body and then removed once saturated for the analysis of electrolytes. Now, based on sweat testing data, we can advise and provide recommendations because, of course, all drinks are consumed on a voluntary basis. In my experience, educating players on how to monitor their own hydration status and how their fluid requirements change depending on the exercise and on different occasions is the strongest tool for driving voluntary fluid intake. So we repeat the sweat test at different exercise intensities and environmental conditions, as we've discussed, but also during different types of exercise. So either on the field or during any supplementary work, such as resistance exercise. And this can generate individual reports, which we can communicate verbally, but typically in combination by sending the results out and reminders to the athlete's telephone, allowing us to build this profile of hydration recommendations. Now, this slide highlights some of the limitations around our current methods, especially the field method to measure sweat profiles in athletes. Mainly is that it is very labor intensive. It requires a scientist to be in the field to conduct the testing, to analyze the data, and to generate the reports. And this time commitment becomes amplified when testing with teams with larger squads, such as American football, for example. Other limitations include, we know that a one-off urine sample for pre-exercise hydration is not an accurate measure in isolation. But urine indices should be combined with daily body mass monitoring and subjective sensations of thirst. Furthermore, weighing drinks bottles before and after exercise gives little insight into the drinking pattern and behavior of the athlete. And also, as we've mentioned, as athletes sweat differently depending on the intensity and environmental conditions, we need to repeat this process ideally. And this is therefore more labor intensive and time consuming, both for the practitioner and the athlete. Now, one way in which technology has improved the field sweat testing protocol has been the advanced equipment provided for the analysis of the sweat. Now, historically, sweat samples would need to be collected and analysed in the lab, which would be expensive and result in a delay in the feedback which we can provide to the athlete. And this is why we look to develop a portable, quicker, cheaper, but reliable and valid tool to measure sweat sodium. So in 2014, Lindsay Baker and colleagues at the Gatorade Sports Science Institute collected sweat samples from 7 anatomical sites on 30 athletes during a 1-hour cycle in a heat chamber. Now, after removal, 1 patch per site was centrifuged, and the sweat was analysed by either the gold standard lab technique, which is the HPLC, or by using this portable Hypohydration device pictured in yellow. Now, the validation of this device would mean that the sample could be analysed close to the end of the test and reduce the time from the test completion to the results sharing. And this study found a strong correlation between the Hypohydration syringe technique and the HPLC centrifuge analysis, meaning that the Hypohydration can now be used as a tool with confidence to measure sweat sodium concentrations. However, this method is still reliant on a scientist being present. Now, to overcome this limitation, GSSI partnered with Northwestern University and Epicor Biosystems to develop a single-use wearable patch, and we call this a GX patch. Now, this patch can collect sweat through small inlets, and the sweat transverses a channel which passes through an orange dye on the sweat rate side through microfluidics. The local sweat rate can be then measured simply by measuring the distance that sweat travels through the channel. On the upper end, the sweat passes through a colorimetric assay that can measure the concentration of electrolyte in the sweat and via the concentration of that purple color in the channel. And you can read more about the validation of skin interfaced microfluidic systems by following this reference, again by Lindsay Baker and colleagues, published late last year. And this year, for the first time, Gatorade made this technology commercially available. The patch works in conjunction with a GX application on smartphones and devices. So when an athlete is finished exercising, they will open the app and they scan the patch. The app then takes the photo and then instantly predicts the sweat rate and sweat sodium concentrations of the athlete for that particular exercise. These recommendations are based on bespoke GSSI algorithms, which can be applied to that data to give the athletes recommendations. After building up a profile, the athlete will receive recommendations, not just on hydration, but the GX application has the capacity to build in other sports nutrition considerations, such as preparation and recovery. And the patch is just one component of an ecosystem of technological tools, if you like, surrounding hydration and sports nutrition. These include a GX weighing station, a smart bottle, which will give us real-time drinking, real-time fluid consumption, and then if we know the composition of the beverage in the bottle, it will also give us real-time carbohydrate intake. And then this system will then be linked to a range of personalized hydration products. And ultimately, this is designed to help build a profile to inform individual fluid and sports nutrition requirements. So in summary, hydration is an area of nutrition science we can easily monitor and influence the player's behavior through recommendations and careful planning. It is also an area of nutrition we can personalize to the individual player based on their unique sweat rates, sweat composition, training environment, and competition requirements. It's important to emphasize that it's important to practice any given hydration strategy, especially when combining it with carbohydrate ingestion. But gradually, these technologies discussed today and beyond will become more affordable and as such more accessible to athletic populations. Therefore, if we consider the impact that new technologies will have, it will be the rapid and widespread monitoring of the athlete's hydration status during training and competition. And these insights will allow us to link hydration practices to performance or other key outcomes that the athlete or coaches can better relate to. Speeds, distance covered, pass completion, injury, for example. Ultimately, incorporating technology will give us an approach to give us more information on the individual tolerances and personal requirements to better maintain the player's health and athlete performance.